Hey, hi, hello, this is Miss Wilkes, and in our video lesson today, we're covering Chapter E with a little bit of 14 in it. It has graphs, slopes, and lines. I did a little bit of coding for you. So right here, we're looking at 48%. So the lines is going to be this piece. And then right here where it says loans for 58%, just to help you correlate those. Part A. In which year did home equity loans first fall below home equity lines of credit? So whenever you're looking at this and we're following this line, that's where our path is. Do you see where they cross each other? So we need this year that's here, which corresponds with the year 2004. Part B. What does this line graph represent? So whenever you want to know your representation, you're looking at the title graph. Or excuse me, the title of the graph. That's going to be the friendly bank. What variable is represented by the y-axis? The y-axis is your vertical axis. So it's right here with percents. Your x-axis is horizontal. That's this one right here. It says it's our time. It's being written in years. There you go. And then part E. What was the percentage for loans in 2006? So still looking at loans, that little blue mark that I had made, 2006 would give us, I'm going to say 32%. What year did those reach 52? So we notice that we're going to reach 52%. Let's find it. 52% is about right here. So that's going to be right along this line. So it would match that 2007. Part F. How much greater were sales in 2006 compared with the year for 52? And that should be 52%. And also, I should have written this the other way. I should have asked you to compare from how much greater 2007 was to 2006. We are simply going to subtract those values. So 52% subtracting 32% will give us a 20% difference because the 2007 year was greater. Using the multiple line graph, equity lines of credit versus equity loans, answer the following question. In which 2 years was the percent of equity loans the same? So equity is the solid line, and when they're saying the same, it actually means constant. So you're looking for a segment that's going perfectly left to right. And we can see that right here. And that's sandwiched between the year 2006 and the year 2007. Okay. Moving on, my loves. Use the line graph to the right to determine what speed gave the highest gasoline mileage for both. So I would look, honestly, right here. This is the highest point of the dash dotted, and this is the highest point of the solid, and it corresponds with, I can't read that. Oh, that's a 5. So 50 miles per hour. Using the line graph to the right, calculate the amount and percent of increase in the employee's salary from 2005 to 2006. 2005, 2006, 5, 6. Notice it says that we're in thousands. Pardon me. So we're going to start off with our new salary of $44,000 and subtracting the old salary of $40,000. So our amount will be $4,000. Then we need to actually calculate the percent. So to calculate the percentage, you take that difference and divide it by your original. And that's going to be equal to 0.1 as a percentage. That's 10%. Construct the following graph. Monthly sales for one product line are based on advertising and can be approximated by this linear function. I know it's linear because the highest degree is a 1. Graph this relationship if advertising does not exceed 1,500. Okay, so ba-da-dum, ba-da-dum. And this side is going to be where we're starting at. So I want you to look right here. This 25,000 is our slope. So we can simply go like this, and that's going to be where the 25,000 is. If you prefer seeing them as ordered pairs, the x coordinate is 0, and the y coordinate would be the 25,000. Now, you're not exceeding, which means you cannot go past that 1,500 in advertising, and this is our advertising line, and this would be like our sales chilling up here. So if you take your 1,500 and plug that in, your sales will be equivalent to that increased by the 25,000. I'm making that $68,200. Or again, if you'd prefer the ordered pair. So you're just going to pretend, because I don't actually want to sit here and actually count, because I'm a little lazy. I'm so sorry. Pretend that's at 1,500. And then I'm just going to put a dot up yonder. And we're going to pretend that correlates to 68200. And then just connect them. No arrow, because you're not exceeding, meaning you cannot go past the 1,500. Pardon me. A boy decided to start a lawn mowing business. He plans to charge an average of $60. He thinks that the cost of buying and maintaining the equipment needed, plus operational expenses such as gasoline, will be about $7 per yard. So when you're expensing, when you have an expense, that means your price is going down. So he was going to charge $60, right? So to figure out how much you make per yard, let's do 60 and subtract our 7. So we're going to be at 53. That's how much he'll make per yard. P is for profit, N is for the number of yards. So pay attention to capital and lowercase whenever you're typing in your answers. It'll look like that. Your graph, I think the easiest one would be right here. Just sit right there at 0, 0, because if he mows 0 lawns, he's going to have $0. He can mow no more than those 8 yards per week. So whenever you plug in your 8, 53 times 8 will give you 424. So then we're going to say that this is your 8 because this is your yard count. This is your money count. And again, you're just going to pretend with me because I'm being lazy. Pretend that's 424. So they would intersect right here. Connect the dots. Don't make an arrow. The slope of a line compares the blank change, or the rise, rising is the vertical axis, to the blank change, the run. You run from left to right. You rise up and down. So this one's going to be horizontal. And remember that slope is depicted by the letter M for that modulus. So rise divided by run. Ta-da! Find your slope. Okay, so we're going to go from one point to the next point. I'm going to get really close on here. If I make an L, it actually ends up making it look like a triangle, like a right isosceles triangle. Sometimes they're equilateral. It's great. This one, I went down 1, 2, 3, 4 boxes. And then I went to the right 1, 2, 3 boxes. When determining my slope, I would put my rise on top of my run. So my answer would be -4/3, or you could say 4 and -3 as such. As long as they're both not a negative, then you're safe. Oh, that one's fuzzy. As people age, daily stress and worry decrease and happiness increases, according to analysis of that many adults in those ages in a certain country. So part A, finding the slope. And they give us our 2 points. We know that this is the x-coordinate and the y-coordinate, the x-coordinate and the y-coordinate. Using substitution, we would have 56 subtracting 31. Those are my y's. Or maybe you did 31 subtracting 56, it's the same answer. Actually, I'm going to follow the formula exactly how it is. That way you don't go, oh, what? What in the world? So I'll do 31 subtracting 56, which then means I do 62 subtracting 22. All right. From here, I'd get a negative 25 on top. Ooh, and a positive 40 on bottom. A calculator would provide me with the decimal answer of this. So negative 0.625. On your Pearson platform, it will tell you to round to one decimal place. So we are going to round and say negative 0.6. Okay, part B. Use the answer from part A to complete the following statement. For each year of aging, the percentage of adults reporting stress decreases by 0.6 or 0.6%. Because it said decrease, that's why I did not put the negative. But anyways, the rate of change, there we do need it. So it'll be negative 0.6. And that'll be percent per year of aging. And that'll be like in this little drop down box. You won't actually have to type year of aging. Please scroll. My thing is stuck. Oh, never mind. All right. You and your friends have joined an after-school fitness program. You record your weight at the beginning of the program, and each month thereafter, the table and the graph below give your weight W after a 5-month period. Answer parts D through F. All right. Connect the points 0, 180. Let me color code for you. 0, 180 is chilling right here. 3 with 166 is chilling right here. So if we connect the lovely dots, it'll look like this. All right. So does the line segment rise, meaning it goes upwards, fall, or remain horizontal? Well, ours, as you can tell, it was falling from left to right. What is the practical meaning of the average rate of change for the interval in part D? Okay, so if we actually calculate our interval, we would have to do the 180 subtracting the 166. And then if we go from 0 to 3, we're doing 0 minus 3. That piece, whenever you go for it as a decimal, you're going to be at negative 4.7. So we are losing weight at about 4.7 pounds per month. Notice we did not put negative 4.7, you said losing. And your average rate of change would be negative. Looky there, guys. So cute. Oh, not payroll. That's later. All right, now we're here. No, that says it. Let me learn how to read, I apologize. It is projected that one of the fastest growing occupations between 2003 and 2013 will be home health aides. During the 10-year period, the number of home health aides can be approximated by this equation. Lots of writing. Okay. They want us to go into slope intercept form. So simply we're going to distribute 4 times 8 is 32, keeping the x. 4 times 90. What is that? 360. Part B, the slope is your coefficient. So the number that's in front is that 32. So our slope is 32. And since that 32 is a positive, that means that we are increasing. Look how good we are at this. Okay. The estimated life of an asset is 16 years. Determine the annual straight line rate of depreciation. Y'all, this one's so easy. It's essentially saying that you lose 1 year for each year that lapses. So your ratio is simply this. And if I do 1 divided by 16, I would produce this decimal. So as a percentage, and it says to round to the nearest hundredth, I'll be at 6.25%. Similarly, the cost of an asset with an estimated life of 26 years is that, and it has a no scrap value. So again, here we go. That straight line tells it's going to be 1 for every, and there's my 26. You're going to multiply that by your value. Alexa, volume 3. She gets a loud sometimes. I'm so sorry. Okay, that will put us the annual depreciation. So each year it lowers in value by $6,500. Okay. Oh, so sorry. Find the annual amount of depreciation using the straight line method. So cost, life, and scrap. So take these two values, chilling right here, and you're going to subtract those. When I subtract 600 away from that 3,900, I'm at 3,300. My 5 years is going to give me that rate of 1 to 5, or 1/5. So then we're going to go with the 3,300 being multiplied by 1/5, and that will produce your value at $660. Dun, 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 dun. Again, depreciation, meaning it goes down, 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 down. You're losing money each year. A tractor costs this much money, expected life of 10 years, and has a salvage value of $2,800. Use straight line depreciation to find the yearly depreciation. Make a depreciation schedule for the first 3 years. All right, darlings, here we go. Take these two little homies, and you're going to subtract those. So when you subtract those two values, you're going to be at $18,500. That is your depreciation, like right there. Like that's how much you're able to lose over time. We know that we have 10 years, so we're going to take a 10th, 1 out of 10 for my year, and that'll put me at $1,850. So every year you lose $1,850. So let's go ahead and put $1,850 into each of these. Column 2. We can also go for year 1 and put our $1,850 for our accumulated, meaning how much we've lost overall in our lifetime. So now I want you to take these two values that are right here and subtract those. So 21,300 minus 1,850. That will put you at $19,450. So then when we're at year 2, that means that we would have 2 of these. So 2 of the 1,850 puts us at 3,700. And one more time, you're going to subtract, and you're going on that piece. So whenever you subtract away that 3,700, you're at 17,600. Now, to be clear, I just want to make sure you did subtract correctly. You did the 21 minus the 3. Always go back to that original book value. Okay, last one. Do it by 3. 1,850. So we're at 5,550. 5,550. Subtract that from the original book value, and we're going to be at 15,750. Your other option is that you start with that book value, subtract 1,850, subtract 1,850, subtract 1,850. That's your other way to do it. Okay. Ooh, this is the last one because now we move to payroll next. Okay, a bottle capping machine costs $27,000. It has an estimated life of 3 years and has a scrap value of $6,000. All right, so take these two numbers, subtract. That'll put you at 21. No. Yes. Okay. Given that your time is 3 years, you're going to do the ratio of 1 to 3 to keep it a straight line. So calculating a third, 21,000 divided by 3, 21 divided by 3 is 7, so I'm at 7,000. That's going to be how much I lose as a percentage. Oh, okay, I'm so sorry. I have like a squirrel moment. I want to make sure y'all understand, if they ask you to write your straight line method as a percentage, I would take this little dude right here, and I do 1 divided by 3, and I get 0.333 repeating, right? Which is the same thing as 33.3%. Just make sure that you have that. It's another question that you'll have later. Not with me, but like on homework. Okay, what am I doing? Oh, yes. Okay, part B. So this is my rate. So the annual amount that I depreciate by is going to be $7,000. And at the end of the first year, so we just have to do our 27 original book value, subtracting 1 year of depreciation. So your little machine's only going to be worth $20,000 at the end of the first year. Okay, that is all we have for this video lesson. Let me know if you have questions.